All right, kiddos, the last thing you are responsible for in this section of the covalent bonding section of chapter 6 is what a hybrid is in hybridization. Okay, so a hybrid is a blend of two or more things. And hybridization is actually how we are going to see how we get equal bonds of equal energies between all of our different atoms. Okay, so essentially what's happening here is the mixing of two or more orbitals. And these orbitals combined and rearrange, because remember, they are all valence electrons, to show that we can have four equal bonds. So there's lots of different kinds of hybridization. There are hybridizations of the s and p orbitals, s and 2p orbitals, s and 3p orbitals. And this is the one that we're going to look at here in honors. You'll look at the other ones in AP chemistry when you end up taking that. And what we see for this sp3 hybridization is that we're going to take our 1s orbital and we're going to take our 3p orbitals, and we're going to see that since these are all outermost electrons, and according to the off-ball diagram, their energy levels are so close to one another that they end up combining and making four equal orbitals of the exact same type. All right, so let's take a look at carbon. Carbon has the electron configuration of 1s2, 2s2, 2p2. So its valence electrons are going to be these outer ones here, 2s2, 2p2. Those four valence electrons have two unbonded ones and two bonded ones. So how does carbon make methane? How does one of these bonds make any difference between one of the hydrogens and another one? The answer is they don't. They're all equal, which is where we get this concept of hybridization from. So it takes that 1s orbital and the 2p orbitals and it smushes them together into four equal sp3 orbitals. And just like what Hund found is each one of our electrons enters one electron in each one first so that they can make four equal bonds and then they would double up. Now carbon makes four equal bonds so that they can make a variety of different kinds of structures. So it's really kind of amazing that they're able to determine that this is what happens in all of our different wonderful chemical compounds. So this is your carbon tetrahydride, also called methane, and you can see how you have four equal bonds with a bond angle of 109.5 degrees between them, and there is no difference between any of those hydrogens or any of those bonds. Okay, these two websites here are pretty awesome. They show, I'm going to move this over for you so you can see, they show different examples for your practice pages and looking at the different options for your different hybridization and showing your sp3 hybrids over here. And then you can go to the practice page and figure out those as well. So there's plenty of stuff to do here. And then here is another awesome little summary table that's going to be linked in the notes so that you can kind of find what all your different types of orbitals are going to be. And you're mainly responsible for these right here with 2, 3, and 4 as our steric numbers, and how many lone pairs you have and whether they are linear or tetrahedral, and then what your geometries will be. So this is a nice little summary slide here as well. All right, everybody, that is hybridization.